Buenos días, buenas tardes a todas las personas que hoy nos acompañan, dependiendo del uso horario de su ciudad. En este momento en Colombia son las 11:30, en la costa este de Estados Unidos las 12:30 y en mi caso Argentina es la 1:30 p.m., o sea que estamos justo en medio de mi hora del almuerzo. Bienvenidos a esta nueva edición de Andina Virtual, donde vamos a tratar un tema muy importante. La revolución digital ya está aquí, no hay vuelta atrás, no hay manera de deshacer los cambios que han ido aconteciendo en este último tiempo. El coronavirus y los efectos de la cuarentena han repercutido en un cambio en nuestros hábitos de vida. Nuevos requerimientos de Internet, trabajar desde la casa, encuentros virtuales, entrenamientos remotos, que se suman a lo que ya venía creciendo en lo que es el Internet de las cosas, el Smart Cities y los requerimientos del 5G. Todo esto agrega mayor presión a nuestras redes de core y a nuestras redes de acceso. Hoy tenemos con nosotros a Steve Harris. Es un gusto para mí presentarlo a Steve. Más allá de un buen profesional, es una excelente persona y un buen amigo. Creo que son elementos que valen más que cualquier galardón para una persona. Steve es un profesional de experiencia reconocida en el mercado global de las telecomunicaciones. Su actividad estuvo enfocada mayormente en toda la actividad de training y capacitación. Es director ejecutivo de entrenamiento y ventas técnicas para el SCTE, la Society of Telecommunication Engineers. Trabaja con el SCTE y con el ISBE, International Society of Broadband Experts, y lleva con este grupo trabajando casi 11 años. Pero no solo estuvo trabajando con el SCTE, también continúa trabajando con Cisco en la parte de como instructor del Cisco Academy, y también estuvo trabajando en otras empresas como Comcast y Camden County College. Bueno, esta presentación va a ser hecha en inglés. Hablé con Steve para que sea una presentación lenta. La mayoría de ustedes hablan español e inglés y algunos quizás solo inglés. Por eso, bueno, good morning, good afternoon, everybody. Welcome to this new edition of Virtual Andina Link. As I told you before, digital revolution is here. There is no possibility of turnaround. There is no rollback. All the changes are almost forever, because this coronavirus and the quarantine changing our lifestyle. Home office, virtual meetings, remote training, IoT, 5G, smart cities. All these new things requires better internet connectivity, requires access everywhere, and apply more pressure to our core and access network. ODN will play a key role in future networks. Steve will explain more about what ODN means. ODN is optical distribution network, because any future technology will be based on ODN. That's the reason why I said ODN is the key. Steve is a good and well-known professional in the telecommunication market, not only in America, also worldwide. And the main focus of his career is devoted to training. He is Executive Director of Training and Technical Sales of SCTE, the Society of Telecommunication Engineers, that is based in the States, but with several chapters all around the world, specifically in Latin America. Is the CALA, is a chapter with Hispanic-speaking people. I also invite you to join the CALA chapter of SCTE. Well, Steve, the audience is yours.
Thank you, Juanito, and thank you, Andina Link. And I want to thank everyone who has taken time out of your day to attend today's webinar on the optical distribution network. And I hope by the end of the session, you'll have an understanding of the technologies that make up smart cities and kind of a little bit of the direction we're going with all the technology. So just as an introduction, or my icebreaker, you know, one of my favorite movie series is The Terminator. And when you think of smart cities or future cities and how they could rapidly change our urban areas for the better, you might think of Skynet, or you might think of Terminator, where in this scenario, these cities were improved and life was improved for many citizens. However, Skynet, through machine learning and artificial intelligence, decided to take over for itself, all right? And that's not the kind of smart city that we were referring to. But, you know, it's always something you think about as you gander at smart cities. We're really looking at a city that really improves a life for its citizens. So we're going to introduce the technologies that make up the smart city and also talk about how they fit together. So here, let's talk a little bit about smart cities. Again, we want to take advantage of the latest technology. And as you can see here on my screen, there are several connectivity platforms. From the far left, the hybrid fiber coax, which is transitioned into what we call CCAP, the cable access, or the converged cable access platform. And you know, a lot of movement has happened over the HFC in the past years. However, we could see there are 4 other architectures here on the screen. And these cities will be able to take advantage of a provider's infrastructure, whether it's far left or in the middle or over to the right with DOCSIS 3.1 or 4.0. And cities are also well suited for the transition to advanced infrastructures, such as XPON, which we refer to as like GPON or EPON, XGS-PON, and next generation PON 2 and such, as well as EPON. So shown here, my focus is really to talk about the ODN. The ODN, the optical distribution network. The HFC on the left, and let me see if we can get out here. This over here, the HFC on the left transforms in a scenario over to the ODN. And what you'll notice in the ODN, there's no CMTS. It's now a OLT, optical line terminal. The HFC, the access network, is an ODN. And there's different equipment within the ODN. In this case, a multiplexer that will house optical splitters, that will house maybe passive, active devices and other passive devices, as well as connectors, erbium doped fiber amplifiers, and such. And we'll explore that. And as far as CPE, some changes around that. whether that's a optical network unit or an optical network terminal. And that really depends on in what flavor PON, in this case we call XPON, what flavor PON that you're doing. Also to consider here, to the right of the ODN, the Fiber Deep network, Fiber Deep is also a great launching point for an ODN as well. So let's not discount that. And then a lot of operators, you might have heard the term distributed access architecture. Well, that's another great launching point. You know, here we have a remote PHY device, you know, a remote PHY node, but inside is our remote PHY device that provides connectivity to DAA. Well, within that, we're able to launch an ODN. So that's also available. So hopefully we painted a little bit of a picture of the architectures, but we're going to dive in deep on the ODN and the technologies that will run over top of the ODN. You've seen many slides. We've all seen numbers like this. Many of the presentations that you've had attended in the past, I'm sure you've seen this, right? The fact remains, as many of the connected devices will now be found in cities. So we know there's going to be a lot of connected devices. We know in your home, you have more connected devices today than you ever did. But everybody is sharing in the billions that will have connected devices. And most times you may just think of, you know, smartphones that I have listed here. You might always think of that. But now there's sensors, all types of sensors, and we'll explore those. And these sensors can everything from pest control to the sensors they're putting in your vehicles, and we'll talk a little bit about that. But there are many, many devices, and a lot of these will live in your cities. So the question is, how do we take advantage of those devices? And how do we leverage our optical distribution network? The optical distribution network is what's delivering passive optical networks. In many cases in Latin America, that is GPON, Gigabit Passive Optical Network. And also, if you haven't heard about 10G, I'm going to do a little introduction because the ODN, the Optical Distribution Network, is a key component under the 10G platform. So the 10G platform is all about driving innovation in the ODN. 10G is a partnership, as you can see here, with NCTA, which is a government arm of the cable industry in the US. Cable Labs, which a lot of you are members of, is our forward-thinking engineering, looking out 3-5 years on what's coming next. You might have even seen some of their videos. They're excellent. There's also Cable Europe, and of course the SCTE. Now the platform offers increased reliability, and who doesn't want reliability? We all talk about that. I mean, no longer can you have a network that's down for a day or even for a few hours. Expanded capacity. Everybody's excited about more capacity. Everybody wants symmetrical networks. Of course, we want better security. I'm sure in the last few weeks, you've read an article or come across an article in the last few months talking about cybersecurity, talking about hacking. We're going through it in the US. All different countries hacking the US, and it happens in every country. But that's important to have better security. Obviously, lower latency with 5G coming, gaming, more video, virtual reality, all key components. One of the things that operators are keen on is service velocity or agility. That means I'm able to scale my networks up when I need to, and I can do it very quickly. And finally, a component of 10G is performance, higher compute. So in addition to 10G edge computing, which allows processing at an aggregation node listed here. So you can see that right here called the edge node. You may have referred to it as the aggregation node. I will also talk about GAP, Generic Access Platform, coming up. But key component in the delivery of an ODN, of a smart city. ODNs today support 10 gig. There are networks by the ITU, the International Telecommunication Union, called XGS PON that support 10 gig. And there's 10 gig EPON, and there are also specifications and standards beyond 10 gig. Don't forget the DAA networks are also able to leverage ODNs. So let's talk a little bit about the components of 10G. And really, these are components of an ODN. And the 10G is a platform for delivering improved reliability. Think about what's happened in the pandemic. I just had a conversation this morning, somebody that's using telehealth and telemedicine for their children. And this is important. You have to have reliability when it comes to accessing healthcare, as well as devices that may monitor your healthcare. And of course, let's not forget about proactive network maintenance that many of you are working on. That's also falls under improved reliability. We also have bandwidth. Bandwidth will be fast enough for the ODN technology coming in the next 10 years. So we're talking 10 gigabit per second. And we want to scale that beyond 10 gigabit per second. And we want upstream bandwidth matching downstream bandwidth. And an ODN has that capability. And an ODN, beyond that capability, is able to leverage digital fiber. And we'll talk a little bit about that. Let's talk about security. We mentioned cybersecurity, but other areas of security, public key infrastructure. No longer can we leave things at a low security level. IPv6, a lot of folks are transitioning to IPv6, IPsec, which is IP security, and creating more secure networks. Think about this edge device that's moving out into the network, right? And it has edge compute. No longer can that, you need physical security, but no longer can we not protect that device. And there's some great articles in the latest issue of Broadband Library that talk about this type of security. And we have reduced latency. And the key with reduced latency is, how do we aim for 1 millisecond? Right? How do we get to 1 millisecond? And you say, wow, that's crazy. But think about what the customers want. More mobile devices. They want to leverage 5G. They want to use Wi-Fi. And not only is the ODN need to deliver 1 millisecond or close to 1 millisecond, also our Wi-Fi networks need to do that. We're going to be doing mobile backhaul, front haul, and that's going to be riding over top of the ODN. There's a lot of mobility happening in cities. So that's key. Service velocity. This is the scalability and agility of an operator. If you have customers, they don't want to wait weeks or months to use a particular service or sign up for service. So it's important to make sure our network scales very quickly. And you might have heard some terms around software-defined networks or network function virtualization that really improves that. Even SD-WAN, software-defined wide area networks. And of course, performance. Performance is key. And so higher compute that drives performance, and this is necessary for future cities. We'll talk a little bit about fogging, because that's related to performance as well when it comes to cloud. Also to mention is, besides training and certification, standards. And SCTE develops standards. We're a nonprofit that develops standards. Cable Labs develop specifications, and we're all using these specifications and standards. And these are important to follow recommended practices and standards. And SCTE, along with the industry, is looking to expand outside our normal standards operational topics. So we're pursuing new technical standards tied to broadband, emerging areas. And this is important. You'll see some of the emerging areas may be artificial intelligence that we're working on, machine learning, of course, smart cities. Autonomous transport and telemedicine are among the few. And you can see here we have some of the groups already started and running. And some of you may be attending some of the groups already. So this is important. It's instrumental as the industry is developing best practices and standards around the ODN. Now, the SCTE standards group was very instrumental when it came to fiber to the home early on. You might have known about the SCTE-174, radio frequency over glass. Perhaps some of you are using it. All the SCTE standards are free. You can access them on our website. There's over 300. And we'll talk about one that really relates to the ODN, and there's a lot of activity. And there's been a recent article from Light Reading as well. It's called the Generic Access Platform. Now, this standard is going to enable the ODN of the future. So stay tuned, and we'll talk about that. The SCT GAP defines common interfaces that basically allow you to do plug-in modules within your aggregation node that I was showing on the last slide. And this will enable not only ODN, but DAA with ODN. So stay tuned. Lots to come on this front. So let's talk a little bit about smart cities. Now, I'm not sure if we have a chat feature. My moderator would know that. But it was just a simple question. What is a smart city? And we may come up with many, many definitions of a smart city, right? But I wanted to make sure that we're all on the same page. Juanito, do we have a text feature? I'm not sure. So that's okay.
Not sure. Continue.
Okay, no problem. And so think in your mind, what is a smart city? And I'll show you a definition. This is according to Wikipedia. Let's see if you came up with the same thing. So think about an urban area using different types of electronic things that connect to the internet, sensors to collect data. And one thing recently I learned is that my car is collecting a lot of data about me, the way I drive. So pretty scary stuff. But think about if your car has all that data and you're able to leverage that data, making it more efficient in transport. Now, it's all about the data, and you probably read or heard about lots of articles about data privacy. But the data is excellent for managing assets, all the resources and services efficiently. So hopefully you came up with that definition in your head. So let's take a look at some settings. These are just examples. This is not an exhaustive list of things that you would find in a smart city, but kind of gives you some ideas. These are 9 settings of a smart city deployment. And these could all be enabled over the ODN. So I'll start with my favorite over here. See where my pointer went. Okay, we're going to start with vehicles right over here, and then we'll work this way. Okay. So we at SCTE are looking at autonomous transport, autonomous vehicles, part of the SCTE Explore program that I just mentioned. This will be a key enabler of a smart city. And we'll talk a little bit more about some of the challenges of vehicles today. And do you think people are going to migrate to cities in the future? The answer is yes. So the challenges we have today will continue. So vehicles is a huge part of this. Now, we talk about home automation. This is just an extension of a smart city. There are many homes in a city. There are many multiple dwelling units in a city. So you can see in the billions, these markets. And who doesn't want an automated home? Who doesn't want a home that can monitor temperature or moisture, et cetera, et cetera? You have offices. So as we work across the area, we have our offices here. And again, the offices are changing, especially with what's happening now. So this is an extension of a smart city where you have teleworkers now working in different parts of the city instead of a single building. So there'll be a lot of opportunity for this area. So we talk about factories could be another area that will benefit from optimization and safety. A lot of the technologies that we're talking about will benefit the workforce. How about retail? It's already happening in the United States that we have automatic grocery checkouts. If I go to the Whole Foods, which I do not shop there, but if you did, you can actually just walk out of the store with your devices with your device and your groceries, and it would automatically deduct it from your account. So these are some things changing in retail, making it easier to shop. You have work sites listed here. So here's work sites. These will benefit from optimization. Safety is always important in a work site. How about shipping and receiving? How about container ships coming in and dropping off goods? Lots of opportunity. And these are all part of a city. I mean, it's a huge part of Buenos Aires. And think about yourself. How will you fit in? Do you have any wearables? A lot of people have watches that tell you when to exercise, tell you that your heart's beating too fast, tell you you haven't walked enough. But these will be a key device that provides data within a city, allowing you to navigate much easier, perhaps finding your parking, working with the next one called outside. So outside is logistics and navigation. So in logistics and navigation, it might be moving some trucks in and out of the city. It might be moving you in and out of the city and providing real-time communications via your wearable. So you might be walking through the city and it says this is a better way to go to get to your vehicle. And of course, public health and transportation is a big one. You could even include public safety. So these are just a few examples. You can see the market's pretty large for these types of settings. So the future city challenges. Well, there's a bunch of key areas, and most people live in cities. So that's first of all. So when most people live in cities, people that live in cities want a positive quality of life. Who doesn't want a positive quality of life? And that involves enhancing every aspect of your daily existence. So whether that's getting your coffee in the morning, whether that's going to and from work, whether that's you socializing, or you get lucky enough to ride in this nice vehicle that I have here on the screen. People want to move around safely, and they want to be able to access perhaps green spaces when they're within their city. They might want to use augmented reality to look at different items within the city. So there's a lot of things, arts, culture, but basically it's an environment that provides the best urban living and minimize hassles of city life. You don't want to be stressed when you come in and out of the city. You want to have a positive experience. And cities are a great place to live. Provide many amenities to people that live in cities, as you know. So what can we do? Some of the challenges. Better utilization of resources. Perhaps that's energy. I highlighted the one transportation. Lighting. And maybe you want to have controlled lighting so you're not wasting energy. Better infrastructure in the city. The more infrastructure, the better connections to Wi-Fi, the better connections to 5G. Those connections to Wi-Fi and 5G are backhauled over an ODN. So that's huge just to provide those basic services. And obviously the social aspects. You know, if I can utilize apps on top of those Wi-Fi and 5G connections to make reservations at my favorite restaurant or to book a hotel very easily, it's definitely going to improve the quality of life. How about pollution? Too many cars, too many people, pollution. How can we reduce that? Again, if we can improve transportation and give better times to come in and out of a city, or improve mass transit, and we can then impact pollution. And safety and security is always top of mind for everyone. So obviously you have cameras and lighting and maybe even notifications that say there's an incident that happened in part of the city, please avoid. So real-time information. And what about this one here? Crisis response. So COVID-19. I don't think any of us get enough information on COVID-19. It seems like we get inundated, but it would be nice to get the correct information or to get information that's personalized to me. A lot of times watching the news, I get general information. But what about personalized information to the city that I'm working in, or the environment that I'm working in, or to how I am navigating within a city? So many opportunities. I shared earlier, you can see the growth. You know, 1950, urban areas were about 30%, but you can see now 50, going from 50% or 55% to 60%. So people are not leaving cities. We might see a little bit of change after COVID. However, I think most people are going to utilize cities, and it's very important that we create environments. But this is just an example showing how population lives in urban areas. This is general, and this would vary based on city to city. And I shared that where I got my source, if you wanted to see if we could look up some of your cities. So the clear thing is urban migration will continue, and we will still have pressures on resources such as transportation and other areas within the city. That's apparent. So how can we make it better? So let's talk about the technologies. And I'm sure you're all thinking to yourself, I've heard of every one of these. And you should. The entire industry has been discussing each one of these areas. All of these together can be utilized within a smart city. So lots of components. So we'll start over here at the ODN. That's the optical distribution network. That's your infrastructure. That's your access network for passive optical networks. And then you have IoT, huge technology. You may have not heard of LoRa, but LoRa is long reach or long range. So the LO is long and the RA is range. I should know my acronyms better. But wide area network. And this is important because we have to preserve battery life, and Wi-Fi uses more battery life than a low power. And LoRa is one of many, and I'll share some others. Machine learning. This is computer algorithms to improve automatically, to actually improve the network automatically. No human intervention. Or perhaps we want to accept those automatic improvements. Then we could have human intervention. But this is definitely topics you've heard of. Augmented reality. CableAds has an excellent video, and at the end, if you want to hit me up, I'll send you some links. But they have a YouTube channel that shows augmented reality and some of the possibilities. Here at SCTE, we're actually working on some augmented reality in our training. Obviously, analytics, huge part, right? So analytics is all your data. And we're going to be feeding data between systems. So that's a huge part. You have virtual reality. Perhaps you're waiting for a bus or waiting for a cultural event, and you would like to experience a little bit of it before you attend. So perhaps you use some virtual reality glasses. You see a 2-minute clip of the play that you're going to, or the opera that you're attending, or you would like to take a look inside the restaurant, or maybe you're on public transportation and you just want to not be there. You can use your virtual reality. Artificial intelligence may also be machine intelligence. And it's kind of my joke in the beginning of Skynet, where machines are smart enough and they decide to take over. But this is happening. There's artificial intelligence that's capable of performing human tasks. So that's happening, and definitely we want to leverage that. We have cloud and fogging. So data storage and compute, big part of our networks. And these are areas not actively managed by users. There's a transition here. Before you actually managed data storage, you manage the compute. Here we can add compute very easily through cloud. And then fogging is edge compute for cloud. So one of the things in SCT Gap is moving edge compute to the aggregation node. Intel has been working very closely with SCTE and are big advocates for this. Then we have backhaul, and you could say front haul as well, but these are packets carried to the core and backbone network. In a city, you're going to have a lot of 5G, a lot of Wi-Fi, a lot of wireless connections. You might even have some LoRaWAN that needs to be backhauled as well. So backhaul is going to be very important. And you can't have backhaul unless you have fiber optics, right? And you can't have an ODN without fiber optics. So fiber is key to everything that we're doing. In addition to these, there are new things, and I wanted to mention this. Cable Labs has been looking at. You might have heard of light field imaging. This is actually monitoring the intensity of light within a scene. And if you're a Star Trek fan, any Star Trek fans out there? Raise your hand. Not that I'll see it, but that's your holograms, right? So I'd love to go into a holodeck. And while I'm waiting for dinner reservations, or maybe perhaps I'm waiting for a meeting, I can go into the holodeck for 5 or 10 minutes, have my coffee. 4K video will be a huge part of smart cities. Most of these, if not all, are part of operators' roadmap. Operators are looking at each one of these areas. So these are key areas for you, the attendee, for looking for career growth. Where's my career going to be in the next 3, 5, 10 years? There's a lot of these areas you might evolve into. So definitely check out things that SCT are doing, and we have a lot of courses in these areas as well. So I'm going to show you a little demonstration of a smart city video that I have, just to see if I can get this to change my pointer. Give me a second here. All right, here we go.
Live better in a smart city. All over the world, our IoT, AI, video intelligence, and analytics are making spaces more sustainable, safer, and easier to live in every day. Our real-time parking data helps you find a spot fast, while traffic data helps keep the streets moving, less congestion, and less emissions. Insights about pedestrian and vehicle activity help businesses know where to set up shop and how to better serve their customers. We help the city around you better understand how to keep your streets safe and your air clean. And thanks to advancements in video analytics and 3D LiDAR, we can provide these insights while protecting your privacy at the same time. Real-time transit and capacity data helps riders make better decisions to get where they're going and helps operators get them there on time. Foot traffic and queue analysis helps lines move faster, so you can have more time to do what you want. Hitachi partners with communities big and small to power good, giving you a better, more livable world.
So I thought that was a good short video clip, just 1 minute. Kind of gives you an idea, allows you to visualize some of the things I was talking about. And
Live better in it.
So hopefully you have a good visual of what a smart city is and some of the technology. So let's talk a little bit about the technologies. Next, we're going to discuss digital fiber. Now, this is a key component of the ODN. And of course, the smart cities I just mentioned. And we'll talk a little bit about what does that mean. Okay. Yeah, you may have, and when we talk about digital fiber allows us to have more bits per hertz. There's also coherent fiber, which is beyond digital fiber. Maybe we could talk about that in another session. But that drives more bits per hertz. That's if you're interested in coherent fiber today, you can check out Cable Labs. They have some nice information on their website. But if that's a topic, let Andina Link folks know about that, and perhaps we could talk about that in the future. So you may have seen this before, but however, the Cisco Research Visual Network Index that I'm showing here does an excellent job showing a complete forecast for 2020 and beyond. And if you would like some information on this, at the end, my email will show up, and you could just email me, and I'll send you some information. But some of the key things here, obviously, more users. Whoop, apologize for that. Got to turn my pen back on. Obviously, more users are going to be a key here. If you look at the Cala population on the internet, we're closing in on 70%. More devices, we know that. So those devices are going to want connectivity in cities. So 4 per user, and they're growing constantly. The speed for fixed is growing. Obviously, video consumption is huge, but more and more people are interested in VR and AR. People are interested in Ultra HD, which is 4K. That's growing by a 27% CAGR. We're seeing traffic in petabits for Cala. So obviously, this puts pressure on the network, but the ODN can handle it. The nice thing about an ODN, if you have a 1 gigabit per second ODN today, you can actually upgrade and say go from a GPON to an XGS PON and do a times 10 step forward from 1 to 10 gigabit per second. But what's clear here on the slide, everything is growing. Symmetrical, digital. So everything is growing. And if you're interested in more of this, we'll talk about it later, but at the end, hit me up on my email. Another one that I thought was interesting, and this is also, I can share this with you, is the state of broadband. So this is ITU. This is more of a European versus what I just showed you, which is Cala. What's clear here is the number of people within 100 kilometers, 50 kilometers, 25, and now 10 kilometers. It's growing. There's 2.04 billion people that are within 10 kilometers of fiber. And most of that is driven by the ODN. And these ODNs are delivering packets, whether it's GPON or EPON. A lot of GPON. And EPON is now becoming more and more prevalent as well. So again, this is a free download. If you want the link or you want the document, I'll be happy to share it after the presentation. So that's important. Now we've done with our vendor partners, you can see them right here, Adtran and Corning and some others. We've done some cable fiber outlook survey reports. So if you haven't seen these, this one below here is from 2018. The one above is from 2019. And this early this morning, I was putting some of the finishing touches on some of the stuff that I'm doing for the 2020. So what is this telling us? Well, it's telling us reinforcing the role of the ODN. You're going to see here within this, you have fiber to the home and fiber to the premise. You have 15.61%. You have 10 gig EPON, almost similar, 14%. And you have XGS PON, 11.18%. So these are all areas that support an ODN, optical distribution network. That's roughly 42%. Now, these numbers I'm showing you were from people that took a survey. So these are survey respondents that provided information into our fiber outlook report. So again, these are both free. If you want access to them at the end, I'd be more than happy to share it. The point of this was to reinforce the ODN and how it's going to be a key component to enable future services like the smart city. Now, back to digital fiber. Before I talk about digital fiber, I just wanted to quickly talk about analog fiber. So over here on the left-hand side, I have a node combining plant, which you would refer to as a combiner. So this is our combiner, taking all the RF, if I can draw here, all the RF, bringing that over a single coax and then feeding that into, say, a DFB transmitter and putting it on a wavelength, say, of 1550 nanometers. And then that wavelength going out to your optical node that's out here in the access network. And you're familiar with this. Hey, Steve, I work for the HFC. I know all about this stuff. But a lot of people may not understand is that the signal that we're using here in the optical is analog. It's called analog intensity modulation. While analog signals are good, we have to evolve beyond. So in this case, I'm showing you a 1550 nanometer wavelength over an optical fiber to an optical node using analog signaling. And in this case, I'm using a distributed feedback laser. Well, what does analog require? And you may or may not be familiar with this, depending on your background. Well, we know that analog requires relatively high optical power. So it uses more energy. So example, a typical transmitter output power might be plus 6 dBm. That's close to 4 milliwatts. While a receiver wants to be in the range of 0 dBm to 3 dBm, or like a 0.5 milliwatt. So much different powering than digital. It also operates over short spans. And with smart cities, we need long spans. Not that we can't have smart cities that use an HFC, but more efficient would be using an ODN with digital fiber. And the reason the short spans is because you need more power over an analog optics. And then analog is affected by linearity. And that's typically of the laser diode and or the photodiode, depending on how your system is set up. And of course, noise and distortions. So basically what we're saying, as the link loss increases and the optical power at the optical receiver decreases, the electrical signal at the output receiver also decreases. On the right-hand side, you can kind of see what that analog optic signal looks like. It's called amplitude modulated signal. And then finally, there's the necessity of balancing and aligning electrical signals at the output of a receiver. So you have to do balancing and padding and equalization, and that would be typically over here with your active devices. Not saying you do have to have a little bit of balancing and aligning here as well. But that's analog fiber. That's what we're using today. Now with digital fiber, we're not affected by linearities. So the optical source, typically our laser diode, or an optical receiver, typically our photo diode, we don't have the linearity issues of analog. And we can operate over very long optical links at low power levels, since the receiver must only distinguish zeros and ones. It's baseband digital modulation versus what I was showing you, analog intensity modulation. So that's a big step, utilizing zeros and ones. And that's mentioned right here. So typically by going digital, a typical receive optical powers might be down to negative 20 dBm to negative 30 dBm over an ODN. So much less power than in analog where we're seeing 0 dBm. So the majority of optical links outside the cable industry use baseband digital modulation, and that's the optical distribution network. And this is very cost effective, as you know, as you're deploying these technologies. And it takes advantages of small form factor pluggable modules, SFPs. And it makes it very easy to troubleshoot. I can leverage my toolbox, and I can look at MER, modulation error ratio, bit error ratio, distortions, and PON power meters, optical time domain reflectometers, and there's a lot of tools that I can use to troubleshoot digital. Digital fiber is what's used in the ODN, also distributed access architectures in both of them. So this is a big enabler of the ODN, that we have digital fiber. And whether you're using GPON or EPON, you're using digital fiber. So that's a big win for us. So since I don't get your input, think about this to yourself. Which type of optical modulation can tolerate lower power levels at the optical receiver? Is it analog intensity modulation that's used in the HFC? Or is it baseband digital modulation that's used in an ODN or in a distributed access architecture network? So think about that yourself. You probably have the right answer. Let's take a look. You should have said, yes, baseband. Excellent, excellent. So another thing to mention here, and I've kind of phrased it as a question, because not only are we dealing with digital fiber, but we're also dealing with multiplexed digital fiber, and we're dealing with multiplexed analog fiber. And so the question is, what is the difference between digital dense wave division multiplexing and analog dense wave division multiplexing? And so you might be familiar, before I reveal the answer, you might be familiar with coarse wave. Coarse wave. A lot of operators in their analog fiber networks utilize coarse wave instead of dense wave. And it really came down to cost and versus the benefit. We would love to have dense wave, but it is a little bit more costly when it comes to analog, especially with those increased power levels and the linearity issues. So think about this one. Do you know the answer to this? Okay, so let's take a look. So if you were thinking this, analog channel spacing width is 100 gigahertz versus digital, which is much lower. meaning I can pack more channels on a single core or a single piece of glass. So I go down to 12.5 gigahertz spacing, right? And that's key. You know, as you're turning up a smart city and you need more fiber and you have, you know, digital fiber, I can now multiplex that digital fiber. And I can pack a lot more wavelengths in digital. And then if you look at like channels themselves, perhaps 40 channels versus going out to 160 and beyond. So digital scales better. Obviously, there's some cost here associated as you go smaller and smaller and smaller channel spacing, and then more channels. But this is another technology key enabler of the smart city. Let's get to the optical distribution network. Now, this is the infrastructure that we'll utilize to connect our smart cities. So a couple things to reinforce it. You know, DAA networks are capable of ODN as well. But if we take a look at what we have here, you know, all these DAA networks at the top, deploying, you know, fiber deep or deploying full duplex DOCSIS or DAA, some form of that. So you can see a lot of these at the top, people are going to deploy. Now, the nice thing in fiber deep I mentioned earlier is I could run an ODN off of that too. If I already have fiber deep, why not transition to fiber to the home? And again, the same thing with DAA. I can do ODN. So really nice technologies where I can leverage those. We have people doing RFOG. RFOG really allows you to use your capital expenditures much longer until you're ready to switch over. It's think of it as an extra a mid step. Instead of going right out of the gate with GPON, and now you have to switch to IPTV, I could utilize RFOG and still use existing cable modems and set-top boxes in the home. And then when I'm ready, when those devices are no longer relevant or they've aged out of capital, then I can switch over and then go out to a GPON network or an EPON network later on. Okay. And then we have, obviously, EPON. We have 10 gig. We talked about that. We have XGS PON, which is also 10 gig. Deploying fiber to the prem. So you can see there's a lot of activity around an ODN or technologies that an ODN can leverage. And we also have the SCTE generic access platform to talk about. On the roadmap, and this is just if you're not clear with where things are going, depending on where you are. You know, a lot of operators. There's an operator in Mendoza that's doing XGS PON. Well, you don't have to go out and do 10 gig right away. Maybe I just want to do 1 gig, and then I can just turn it up as I need it. Maybe 1 gig, then 2 gig, then 5 gig, then 10 gig. So it's nice, even if you deploy it, you don't have to go out and run 10 gig right off the bat. You could even start at 500 megabits per second. There is a roadmap for 25 and 50, as well as 40 by 40, next generation PON 2. And there are operators looking at these technologies. So definitely be familiar with different types of fiber to the home optics. And all of these, except for RFOG, leverage the ODN. And what's nice, once the ODN is in place, it's very scalable. It fits under the 10G platform, and I can turn it up. And if I want to go to from 1 to 10, I can do that. So that's the roadmap. Here's another view of the industry's internet packages. Here we are, 2022. And, a lot of us getting to the 1 gig. Maybe we're doing next generation PON 2. Maybe we're doing GPON. Maybe in here there's XGS PON. The other option, obviously, a lot of operators in the US, EPON. But you can kind of see the evolution of some of the technology. So a lot of people moving to the ODN. So we kind of talked about the ODN, but I'll just define it for you. It is your access network. Okay, it is an access network. And it's called an optical distribution network. So this requires operators from an education perspective to do change management. I cannot have someone that supports an HFC now go out and support an ODN without proper training and education and possibly certification, because it's different. It's a hybrid fiber coax network is different than a fiber or an optical network. So the fiber within the ODN carries the downstream and upstream wavelengths, and they use wave division multiplexing. So this is similar to multiple wavelengths found in an HFC. However, an ODN is a dense digital fiber architecture, as opposed to the coarse fiber architecture over analog that I just discussed. So at your head-end facility, head-end, hub site, data center, we have a OLT, and that's an optical line terminal. I don't know if I can write that fast. I'll just write that one out for you. Optical line terminal. And then that will connect into your access network. That's the ODN there in the middle. And the ODN will have maybe your distribution cabinet that will house your optical splitters in there. It will have connector trays, fiber management, and then you'll have optical taps out to your end devices that could be spread across the city, your smart city. So in the case of GPON, that would be your optical network terminal. So GPON uses an ONT. And there's nothing wrong. You can leverage your ODN and leverage GPON to start creating a smart city. And EPON works just as well. So that's an ODN. Another thing to keep in mind that a lot of operators, their workforce was familiar with, is working with an HFC. A lot of the folks were working with decibel to millivolts. Now we're going to be working with dBms here. So you have to transition. You also have to know optical power budgets. And the optical power meters are now PON power meters. So there's a lot of things that change. However, once you transition your workforce, you're ready to go. And the ODN has different architectures that we can do. So shown here on the left-hand side was the OLT, that's right here. You have your transmitters and receiver lasers. This here is a phantom splitter. Some operators may use this just to drop down the optical loss by 3 dB. And the reason for that is Later on, I'll pop that phantom splitter and maybe go from a 1x32 to a 1x64 network. Other operators may not use that at all. But it's a way with the phantom splitter not to have to recalculate optical power budget. So this is your optical power splitter. So typical, a lot of people like the 1x32. There's also operators are using 1x16. And then you have your optical tap that will feed the ONT. This is called a centralized architecture. This is one example. And you could also use a distributed architecture. The distributed architecture is where you have a optical splitter, perhaps feeding another optical splitter. And then you could do distributed tap that kind of looks like an HFC. But centralized is the most prominent architecture for an optical distribution network. And I just listed some facts over here. One key thing is 20 kilometers for optical fiber. Some of the technology will allow you to go up to 1x128. And we talked about the other things. So this is the ODN we talked about. This is the ODN's architecture. Now the technology running over, so we talked about the ODN, and then we talked about centralized. So on top of that, I might choose GPON. And you can see on the right-hand side, there's my OLT. And that's housed up here in my head end. And then I'll have my cabinet out there in the field in my ODN. And then ONTs out at the smart city. And GPONs use 1310 and 1490. And I think a lot of you've gone through a lot of these presentations, I'm sure, about the differences between the PONs. But the key here is I can leverage this technology as well as DOCSIS provisioning of GPON and utilize this architecture out into the smart city. Forward looking is XGS PON, 10 gig. So 10 gig up, 10 gig down. Different wavelengths, I'm sure you're familiar with. But the ability in a smart city, as you start to grow the city, I may also need to grow the bandwidth. And I might need this type of bandwidth in my cities. So that's XGS PON. And that is the next step after GPON for most operators. It's cost effective. However, there's a 4x10 and there's also an 8x10 in the future for 40 and 80 gigabits per second over PON. So what's changed? Well, here, this is the nice thing is once you have an OLT cabinet, is really making sure, does it support GPON? Does it support XGS? Does it support next gen? Because I can just take the cards out and put different cards in. So most OLTs today, they support GPON and XGS PON. And they might also support next gen as well. But if I change the line cards out at the head end and I change out the ONT in the city, I could very easily scale the bandwidth, right? Well, and I don't really need to go into the ODN network and mess around with the fiber distribution cabinet or mess around with a strand mount, what we call a V hub, virtual hub. I don't need to go in and mess around with that because it's already designed for 1 by 32 or 1 by 16. I can change out the endpoints and scale the network quickly. You obviously need to provision that. So that's where DOCSIS provisioning of GPON comes in. And again, with more bandwidth, it allows you to do more things. We talked about mobility right here. We talked about backhaul. Maybe it's carrier Ethernet over PON. We do a lot of carrier Ethernet, which we call maybe E. That doesn't look like an E. E. Private line or virtual private line. So for Ethernet, so it gives you a lot of flexibility. So the ODN is very, very flexible. And here's a little shot. You might have seen this before, but HFC at the top, active devices. We talked about analog. Down here, we're digital, multiple wavelengths, fiber distribution cabinets and V-hubs, and optical taps, and the endpoints could be 1 or 10, and maybe it's 40 in the future. Very, very flexible. Very, very flexible. And you can run these together, meaning you could still have an HFC and GPON, or you could still have an HFC and EPON. And maybe I take my GPON and then connect that into the city. So you can have multiple architectures. So back here we have our DOCSIS provisioning of GPON, which basically makes the ONTs look like cable modems and allows you to use a lot of your back office provisioning, which is right here, and you'll be able to do that. And that's called the DOCSIS mediation layer that I just threw up there with virtual cable modems. And then we have an OLT, and the OLT can support GPON, XGS-PON, or EPON. And then we have our optics that feeds the network. So very, very nice design to put an ODN in, and you could support both. Now I'll show you a little bit about remote OLT shortly, because there's another option. So lots of flexibility. So here's an example, and we don't need to click through this again. So here's an example where those optical taps could be feeding your smart city. So remote OLT. So what we're looking at here, we're looking at this remote OLT, which is what I was showing you in the head-end hub site, perhaps your data center. And we're taking the optical line terminal and putting it in the field. Now there are two types. This is a cabinet. This is a full cabinet we're showing here. Notice there's an air conditioner on it, but a full cabinet. And there's also strand mount. Strand mount uses a SCT gap enclosure, and I'll show you that next. So you have two options, because this might not be viable. I can't put a full cabinet in the middle of a city, Steve. This is not going to work. But in a more rural area, this might be work very well. Or you might have areas within facilities that you can do it, like an OTN. And you can see there's power in here and your batteries for battery backup and all your good stuff. And what we're doing is bringing the edge closer, And for those areas that need to be secure or we do not have the ability to have this, that's where the strand mount option comes into play right here. We also have the ability to have active PONs. So an active passive optical network, you're like, what? This is where we would use EDFAs, erbium doped fiber amplifiers, and maybe we have to extend beyond the 20-kilometer length of a PON. So that's where that comes in. So pretty cool stuff. Let's take a look at GAP. So this is the node. Now you're familiar with an optical node. We called it an optical node because that's what it was called in HFC, because it just dropped off optics. Well, today, it's not just optics. It may be a remote OLT. And that module will slide in here. And with that remote OLT, now I can shoot off an ODN into a smart city. That's pretty slick. Well, I'm also doing 5G. So maybe in another slot is a 5G module. And I could drop that in there. And the nice thing about the GAP, the generic access platform, is you have all your interface connections. They're all standardized. And all the powering is standardized. So you can shop multi-vendor if you need a power supply unit, or you need Wi-Fi 6, maybe you need RF amplifier module. Maybe you're doing DAA. See how flexible this is? So this is also going to be able to be enabled in your smart cities. Modular based, making it compatible with multi-vendors, driving down cost, and improving network reliability, moving the edge closer, and many, many other benefits. So the ODN, I kind of hinted to earlier, and I just wanted to make one point. It's very, very flexible. And one of the things to understand about its flexibility is I have the ability to change the split ratios. So this kind of gives you a little idea of the split. And I was talking about the phantom splitter earlier. That phantom splitter, where if I do a 1x2 split, I'm just dropping it's actually 3.01 dB. And that's for future. I can pop that phantom splitter. So if I put a phantom splitter in and I have a 1x16 network, then I can design the network for 15 dB. Later on, I take out the phantom splitter. I've already accounted for it, so I can easily navigate to a 1x32 by changing the optical splitter. If you want to change from a 1x16 to a 1x32, perhaps then you'll have to account for additional 3 dB. But very, very easy and flexible. So that's the nice thing about the ODN. You're able to grow, you're able to scale. So at this point, I'd like to discuss a little bit about some of the other stuff, the other components. Obviously, we talked about smart cities. We talked about the ODN. I'm going to show you at the end. I did write a nice article that kind of introduced this stuff, and this is kind of where this presentation came from. I built the presentation based on the article, and I'll share that with you at the end. But you can't talk about all this smart stuff without talking about IoT. So if you don't know what IoT is by now, here's a little definition for you. But really, from pacemakers to jet engines, we're using IoT everywhere. And I was giving the example earlier of my vehicle. I have a Nissan car, but my Nissan actually talks to the manufacturer. And the sensors give back information to my manufacturer. And it'll email me a report once a month and say, hey, Mr. Harris, yes, your filters look good within the car, your air filters. It's time to get your tires checked. The oil, all kinds of information, but it gives me a vehicle report. So it's more than, just a thermostat, a light bulb. And they're building sensors into all types of devices. And that's the point I'm trying to drive home here. So each thing, it has its own identifiable information through embedded computing. and it's able to interoperate. So that's IoT in a nutshell. You might be using non-standard solutions with IoT. There is a lot of different signaling types. I'll share some of that with you. There is no IP connectivity needed, which is nice. Devices operate over vertical silos, so I can actually communicate between different devices, which is nice. And there's no single point of access. And you can aggregate it if you want, but that's nice too. So what is IoT? It's low-powered devices. Most of the devices are battery operated. So Wi-Fi is a solution, but however, if I'm looking for longevity, I'm looking for maybe like a LoRaWAN or a Bluetooth or a Zigbee, something like that. When it comes to connectivity, that's shown here. So connectivity could be Zigbee, Z-Wave, LoRaWAN, many different types of connectivity, but non-IP protocols. There are proprietary protocols when it comes to standards. You have to watch some of the IoT devices because some of them don't have any security. And some of them have basic security, like a password. Very, very important as you're going down the list, making sure you have secure IoT devices. You don't want somebody hacking the smart city. You have time to market, and that's really time and effort for development, maybe longer for some of these devices. And then if you could leverage existing silicon chips, solutions that are available, it actually it reduces the time to market, which is nice. And two other things I'll mention. You can see here there's an IoT enabled device, but I want to talk a little bit about cable micronets and security. And so we talked a little bit about being secure, and Cable Labs has been working on micronets, and as security has been very, very important to the industry. This is all about next generation on-premise network management system. So it's adaptive, it's effortless, and it's enterprise level security for home and small businesses that can be extended to the smart city. And it uses the latest technology such as software-defined networking and artificial intelligence and machine learning technologies I mentioned already. So if you want more information there, visit Cable Labs because they're working that. But think of micronets as like a personal network security guard. It manages all your devices, all your connections, monitors traffic flow, and keeps the hackers at bay, meaning it makes it tougher than ever for hackers to bring down your IoT network. So, little information there on that. So what are the devices? What are some of the smart city solutions when it comes to IoT? Look at some of these cool things. Now, if you want more information on some of these things, I pulled this from Comcast MachineQ. Comcast has a division called MachineQ, which is their smart city division. You might be familiar with it. If not, check them out, machineq.com. But it could be something as pest control. So you think a restaurant wants to have pests running around while you're having your outdoor meal in, say San Diego, you're hanging out, having a nice meal, Bogota, you're having a nice meal, and then these pests come around. So you can actually do pest control. Even presence detection. We could detect that someone's there, and maybe we could provide a marketing opportunity. Or we could do leak detection. Maybe there's a fire hydrant, or there's a gas leak, those types of things. Obviously, smart parking would be nice. Hey, by the way, there's parking on the other side of the city, or where you're going, there's several parking options. Would you like me to reserve your space now? Temperature monitoring. That's always a good thing, right? And how about asset tracking. So if you have multiple locations and I need to track those assets between those locations, maybe it's vehicles. Maybe I want to track vehicles, technician vehicles. So there's lots of opportunity here. So I encourage you to visit their website, because these things here, these solutions here, can run over an optical distribution network. What about applications? I mentioned network connectivity. Obviously, fog computing is basically bringing the edge computing, or bringing edge computing in a cloud environment. So in fog, cloud is storage plus IoT. Or think of it as, you could think of it as distributed cloud. And then you have edge devices, routers and switches that make up some of that connectivity as well. You also, under fog, have direct cloud connection limitations. So think about, hey, I have cloud, I'm good. Well, what about latency? What about limited bandwidth? So think about distributing cloud, or bringing edge compute to cloud. That's fog. We mentioned cyber and physical security. I mentioned the data analytics, management of devices and automation, and application enablement platform. So for future applications. So what would those future applications look like? Well, here's a little study from Gartner, and kind of looked at 2018 to 2020. But you can see a lot of the segments, there's lots of use cases for IoT growth. And here we see utilities leading the pack. So whether that's reading your water meter, reading your electrical meter, all of these things are in the billions. So you can see there's multiple devices increasing in under utilities, whereas physical security is like number 2 as growth. So for example, with healthcare providers, the install base goes from 280 million in 2019 to 360 million. And that might be even higher given COVID. Another example is transportation, clear growth, and we are just getting started. And that's why SCTE has a vested interest in autonomous vehicles, because this is a growth area that will touch on broadband networks such as ODN. And I shared the new cars that are already connected. And now is, how do we connect them to the city? And how do we get devices like the city talking to the cars, and cars talking to parking meters, cars talking to each other, cars talking to you? So there's lots of opportunity. And here's a topology example. All right, at the top is your cloud layer. Let's see if I can get my little pen out there. So top's your cloud layer. That's your data center. Could be your head-end hub, head-end site. And then you have your network layer, your routers and switches. And that's really your ISP level up here. And then here's your edge, where you have your controllers. And those controllers are in different parts of the city, where it's controlling lighting, where it's controlling traffic lights. I mean, how many of us waited for a traffic light and you were the only one there? So obviously that creates a challenge. And traffic lights could be more dynamic based on the amount of volume. And maybe be predictive. If they know it's a Friday, the traffic lights operate differently than if it was a Saturday. And so this is where that fog layer comes in, where I can have edge cloud computing. And obviously the devices layer, where it's switches, and these are just some of the home examples. And then I shared some of those pest control and some of the other examples earlier. So lots of key examples there. And it's a multi-protocol framework. So there is some complexity to it. I actually put all join and open connectivity foundation in here, but you can see right here there's 300 plus different types of connectivities available. So many proprietary solutions in the market. As you think about your smart city, think about a solution that, I don't want to go there. Think about a solution that is not so, it's not so proprietary where it may be phased out in the coming years. I know I'm just mentioning LoRaWAN because Comcast has a lot of cities and solutions around LoRaWAN, and they are very active in the industry. But that's just one, right? So the IoT ecosystem evolution status and observations here. Many proprietary solutions, they're going to be converged around like a large consortium and kind of standards attempts. But the key is working standards is really needed in this space. And that's why through the SCTE Explorer program, we are going to work those standards and come up with recommended practices and around this because of having so many proprietary solutions. You do not want to invest in a technology which evolves out of our industry. The most evolved alliance standards are the Open Interconnect Consortium, and that's right here. OIC is a consortium that you might want to check out. Another one is Thread that's catching up, but that's some of the examples. So in here you have your different IoT systems. You have up top, you have your secure IoT interconnection framework. You have your connected home, which resides in a city. And then you have your service provider that might also, its role here is connecting those homes in those cities. So multi-protocol framework. So a few of the IoT protocols, I'm not going to go through all 300 of them, but you can kind of get an idea of some of the ones. Here, you know, RFID for asset tracking. We have smart dust, as small as a grain of salt. So I could just throw out some pixie dust, and now I'm managing everything around me. Not quite, but it's amazing, you know, where the technology is going. Will that smart dust be viable for our industry? That's for our Explorer program and the operators to figure out. But we know Bluetooth is here to stay. We know Zigbee, Z-Wave is here to stay. We know these are here to stay. We know Wi-Fi is here to stay. You know, TCP is not going anywhere. You know, so and another look at this is all these different sensors. Here's all different types of controllers. You know, whether that's HVAC. Maybe you're walking into a public transportation location and it's a Saturday and we might turn down the HVAC because there's lack of pedestrians, citizens, and try to save a little bit of energy. And obviously these sensors and controllers are designed to control all types of different domains. We talked about retail, we talked about medical, we talked about logistics. And then these provide measurements back. So maybe it's thermal measurements, maybe it's imaging, lots of opportunity. So that is my ODN, my smart cities presentation, and wanted to give you a little bit of feel for some of the IoT stuff. I think we can all share there are many technologies that make up a smart city, and it's complex in nature. Now, I don't have all the answers for smart cities, but I wanted to share what the SCTE-ISBE is seeing, what the conversations that we're part of hearing, and you know what some of the activities that we're seeing. There's also a broadband library. If you don't read that, there's also excellent articles around smart cities in that magazine. But my intent here was there somebody talking? No. My intent here was for you to understand the technologies and architectures that enable smart cities, recognize the components of the ODN and how they relate and integrate. And this really allows operators to drive the business results. Really show you how the ODN is the key component of the PON network and how this can be used for smart cities. And then all the different technologies that are available to an operator. So at this point, if we have some questions. Oh, I didn't mean to go that far.
Bueno, Steve, thank you so much for this clear presentation. Antes de pasar a las consultas que han ido subiendo durante la charla, quiero agradecer también a todas las personas presentes, algunos que se identificaron, como Ricardo Acosta de México, Franklin Antonio Lapo de Ecuador, Marco Muscus, no mencionó de dónde era, Ruby Santana de República Dominicana y otras personas de otros países de Latinoamérica, de Colombia, de Argentina, etcétera, que estuvieron siguiendo esta charla. Agradezco también al SCTE por su participación, a Andina por sumarse a nosotros operadores en esta necesidad de capacitación y haber unido fuerzas con el SCTE en esta tarea de transmitir conocimientos. Ambas empresas, Andina y el SCTE, tienen un objetivo común que es el de capacitar. Y la única manera de armar una red de telecomunicaciones para el futuro es sobre las bases del conocimiento. I have a couple of questions for you, Steve.
Okay.
The first is from Marco Muscus, who said that nobody in Latin America is using EPON. I want to share my own experience. 10 years ago, when GigaRed started with FTTH deployment, we had to choose which technology use. We were looking for some kind of global standard like DOCSIS, but there weren't a global standard.
Yeah.
Then look at SCTE, and at that time, SCTE launched the DPoE, DOCSIS provisioning of EPON. Then we decided to go for EPON. But with time, vendors decided to discontinue EPON in the international market. EPON were only for United States and China. All international market was controlled by the ITU, by GPON. What do you think about the future of IEEE standard in the global market?
Yeah, and thank you for that, explaining that in detail, because exactly what you said is correct. I think today, with manufacturers and vendors, they supported an optical line terminal that is very flexible, meaning that you can have an optical line terminal that does both EPON and GPON. So you're able to leverage either technology with a single device. So that means you could have a line card in your OLT for existing GPON customers. You could also have a line card for XGS PON and perhaps one for EPON. I also think that it depends on other types of EPON services you're deploying. In the United States and even in Europe, customers are using Ethernet connectivity or Ethernet links. So if you're using, say, the private Ethernet that I mentioned, it's a great transition over to like an EPON, or using EPON to provide private Ethernet, what we call carrier Ethernet over PON. So I think it really depends on the services that you're providing. I don't think no more it's a lack of technology in the market. But I know that Latin America has used a lot of GPON, and I think maybe vendors understand this, and they say, well, we'll focus GPON, XGS-PON, and the ITU standards for Latin America. And that might be the case. But I'd say you have flexibility now where you can use multiple technologies. The other thing I may offer is, where are you going beyond 10 gig? Now, you could compare 10 gig EPON versus XGS-PON, and depends, you make it close with the vendors as far as cost goes. But as you get into beyond 25 and 50 and 100 gigabit PON, the idea is that Ethernet will become cheaper, more cost effective over time as it's developed by the IEEE and its adoption. But again, that's just prediction. We don't know that for a fact. But that's the thinking, is people are going to want to go beyond 10. And we know that the next generation PON 2 on the ITU side may not be cost effective to go beyond 10 gig today. And that could change as well. So those are some of my thoughts there. Excellent question.
Okay. Second question is a personal question. You talk about remote OLT. I'm just guessing that it adapts for two extreme requirements. In low density areas, rural markets, remote OLT may be a good solution to extend beyond the 20 kilometers range. Are you talking to Alexa, Steve?
No, my office phone is ringing, and I'm trying to end it. Sorry. I apologize.
No, don't worry. That happens. Well, I told you that remote OLT may be a good solution for low density market for rural areas to extend beyond the 20 kilometers budget, the 20 kilometers link of the OLT.
Yes.
And at the other end is in very high density areas, in high density cities, when maybe it's good to move the OLT to the block or to the building to reduce the fiber count required to bring service to a large amount of customers in a small place.
Correct.
Is that correct?
Yeah. So one of the things I alluded to early was the notion of coherent fiber optics. And coherent, different than digital. Digital is zeros and ones, and it's on and off. And you have to flicker those on and off pretty quickly. So think of it as more of a light switch, where coherent is QAM-based digital fiber. And so if you can bring an OLT, well, if you can bring an aggregate node close to dense areas of your city, that aggregate node could then have OLTs connected to it. And there you can provide the density over coherent fiber back to your facilities and then use digital fiber to provide connectivity in those dense areas. So there is that's an excellent question, because in New York City, there's an operator that is doing just that. They're bringing in OLTs into large MDUs, multiple dwelling units, apartments, and providing connectivity for an entire building or an office suite. So you're absolutely correct there.
The problem with remote OLT is powering and the place to locate it.
Yes. Yes. Yeah, because you need, you would have to have a type of service level agreement with a business to drop it off in a business, or have permission from a property owner.
Yeah.
Yeah.
Yep. And you also need to accede to this place late at night or when it fails.
Yeah. Yep. And access because it's locked because you don't have a key. Yes. Yes. And that is all concerned because you may be able to install the OLT at a multiple dwelling unit. However, you might not have 24/7 access.
Exactly.
Yes.
Exactly.
Yes. Yep. It's definitely a challenge. And that's where, an operator may have to invest in, obviously strand mount could be one option, or invest in small, like an optical transport node area within the city to offset that. So you might be in that scenario.
Yes, but in large cities like New York or Buenos Aires, you can't install strand equipment.
Right.
That's a big problem.
Yeah. Yeah, and that's where you're going to need. I think you're going to need agreements with the city so you can have access to facilities within the city to install equipment, and maybe that's some type of an agreement, right? Where you can say, "Hey, we need space for equipment, and we could make your city smart," right? So I think that's part of the conversation with city leadership. And I know that's happened with operators. Working out smart city is not just providing connectivity in your network. It's also negotiating with city council about how it's going to be done and their role in the network, because they are a huge piece of this. It's a different scenario, exactly what you mentioned.
Sometimes to get permission to install equipment in vaults or in pedestals.
Yeah. Yeah. The other, option is you could say to the city and say, look, we'll provide Wi-Fi connectivity at these squares within the city. In return, would you provide us access for this equipment so we can get closer to provide free service for these 3 squares within the city? So you might have to negotiate that, right? Kind of like maybe a more complex franchise agreement.
Okay, another question from Marco Muscus. He asked to explain a little more about edge computing.
Okay.
It's supposed to be some kind of CDN. I guess that you should explain the movement from cloud computing to fog computing to mist computing. The idea is to move not only the content, also the application closer to the user, right?
Yes. And I'm just trying to see if I bring the slide up that it had that here, because I had a slide early on about it. Well, we can look at this one in here. So this is the gap standard I showed. Whoop, it decided to go next slide. Give me a second there. I had it up there and it just, okay. Yeah, so the gap standard, the idea is with the standard, it's all modular based, right? So if you wanted to put a virtual CMTS in there or ON and OLT, you could, right? But the idea is that all that compute, like all the data that you're collecting, you bring that all the way back to your facilities and then do the compute on it. So the idea is with taking all that data back into the cloud and then working your compute is doing a distributed cloud where in this device, instead of an amplifier module, we'll do fog here at the edge and work on some of that data in a distributed fashion or a distributed model. Whereas the other scenario would bring all of it back to the cloud, then do the operation on it, then go back and act on that data. So that it's just a distributed model using fog in a cloud environment. And the other notion outside of cloud and fog is modular head-end architecture. And let me pull that up. So modular head-end architecture is this here. We're doing a lot of this right here. You would like to take this CCAP device and then move it out, the physical layer out into your access network. And that's fine. But now I might want to also slice it and take the Mac and put it out in the access network and basically run virtual CMTS. I'm basically virtualizing my CMTS. When you have that scenario, you're going to need compute out there at the aggregation node. You're going to need compute out there in the access network. So there's the idea of edge computing is whether it's cloud or it's in a modular head-end architecture that the brand new specification, by the way, if you wanted, I can point you to that. It just came out from Cable Labs maybe about 9 months ago, maybe a year ago. That's the notion, is just bringing the compute closer, and this way you don't have to bring all the information back to the facilities to act on it. Does that answer the question?
I guess. Pregunto al resto de la audiencia si alguno tiene alguna consulta adicional, que por favor la escriba en el chat, así yo se la transmito a Steve. Si no hay ninguna consulta, damos por cerrado este webinar. Les recuerdo que este webinar fue grabado y va a ser subido al sitio de YouTube de Andina Link Virtual, y el vínculo para poder visualizarlo les va a ser enviado por correo a la dirección que ustedes suministraron en el momento del registro. Once again, I would like to say thank you to Steve for sharing your knowledge, for being with us, and to join effort in this training task of Andina Link and SCTE.
Yeah, and Juanita, I just want to mention two things quickly, if I could.
Yep.
A lot of these technologies, we have a whole bunch of Spanish courses. So if you're interested in Spanish training, SCTE has a Cala page. Check it out. There's an article around what I just talked about. The key message is learn fiber, get certified, become an expert in fiber, because the operators are going to need you. And the things that I shared earlier, if you want some of those PDF documents, here's my email. And so if you wanted the fiber outlook information I was showing you, feel free to reach out to me or reach out to Andina Link, and we could share some of those documents with you. We'd be happy to share it. That was all, Juanito. Back to you.
Okay. That's it. Thanks again.
Okay.
And gracias a todos por participar.